Alright lads, in this video I'm going to go through the two questions on page 26 of your book. The first one tells us figure 2.9 shows the plan and elevation of a pyramid that's to be cut by the simply inclined plane VTH. Draw the plan and elevation of the cut solid. So you can see there the elevation and plan, and what we're doing is cutting an angle off of the actual pyramid there. So that simply inclined cutting plane is cutting this surface off here. So the first thing we do is get the question set up. So we're told for the actual cutting plane, we draw our XY line first. We're told the plane is simply inclined at 30 degrees. So the line inclined at 30 degrees here, just like that, and because it's simply inclined, we're going to have a line going straight down then. This one is our vertical trace, and this one is our horizontal trace. So we're not told the distance away from the actual shape, so I'm just going to make it up. So first thing I'll do is square base pyramid here. And it doesn't matter what distance is going to be away, the principle is the exact same thing. Your shape could be slightly different depending on how far away you draw it there, but in the book they actually haven't given you a specific measurement to go by. We're told that it's a square of 30 mil, 30 going this way and 30 going that way. And then we can take our centre line all the way up there, and we're told the total height is going to be 60 mil. And we can take our base points up here as well and connect those to the top. So basically, just let that focus. Everything above this is going to be cut away. So all we're going to have left is that edge there, and that there, and then our centre line going down there, and everything else has been cut off then as a result. So the first thing we have, let me draw this there, we can see that this line here is this line here going across, and we can see it's cut at that point there. So we can take that point straight down, and that gives us 1 point here. And same on the opposite side. You can see that this line here is this line here, and where it cuts is at that point there. So we can take that straight down. That gives us 2 points. However, with these two lines from here and here, just let that focus. So these two lines here, we can't actually see where they stop. We have the height here, but we can't see when we go down where it's going to stop. It's on that vertical line. So what we need to do is take a horizontal cut. So we take a horizontal cut with a square based pyramid. We're always going to see a square each time we make a cut. So no matter how many cuts I make, they're always going to produce a square, and from the top all the way down the squares are going to get bigger and bigger and bigger until they become the size of the one we have in plan. So our cut is going to occur exactly at that point there. And what we do then is we take our cut down here. That cut would hit that line at that point. So what we do is we take our lines parallel, draw square and where that cut will take place, and that will be the cut surface then left behind. So just use colour to show it. Say that this orange cut here, exactly at that point, produces this cut here in plan. So Remember, a horizontal cut at all times is going to produce a square in this solution. And depending on how far down we go or up we go, it depends on the size of the actual square. And what that gives us is this point and this point, because they lie along those lines there. So what we can then do is connect those together, and that gives us the plan view of our actual cut then as a result. So our cut surface is that there. Now what we can do is complete the rest of the plan then as a result. Blue to show our cut surface then. So that's our cut surface there. I'll just show that that's from there to there. With our orange being our horizontal cut, which we use to find the point at the front and the point at the back of our square base pyramid. The next question then, same sort of idea, this time we're using a cone, and we're told that figure 2.12 shows the plan and elevation of a cone that is to be cut by the simply inclined plane VTH. So that plane there is cutting it. Draw the plan and elevation of the cut solid. So once again it shows you in the book there 3D model of a simply inclined plane cutting the cone, and this time producing that elliptical shape there. With this question we're going to do the same thing again. We're going to use horizontal cuts, because when we look down on a cone that's being cut horizontally, it produces circles all the time. And we can see there, for example, on one of the points, if I just zoom right in, you can see there that one of those circles there, where it hits the simply inclined plane here, it gives you a point here and a point here on the curve. And that's what we're going to do a number of times to give us enough points to end up drawing our elliptical shape there in plan. So you can see there they're given two examples, radius 1 for horizontal cut there, radius 2 for horizontal cut there, and that's giving us our points there and there and there and there then as a result. So with this one, we are told this time we're actually given the distance away. So what we'll do is we'll just extend our XY line across here, and once again mark it in. And this time we're told the distance is 7 away. So just mark that there, set that to 7 mil. And our simply inclined plane is 45 degrees. And our line comes straight down here. Once again we label it, that's our vertical trace, and there's our horizontal trace. So I show the 7 mil inside here. And that'll be the start of our cone. And I take this line down here, and what I'll do is, it doesn't matter how far away the plan is, take that distance there, and we're told it's a diameter of 74. So I take my diameter 74 there. And then I take half of that then to give me my radius. So 1 into 37. And I can draw my plan. So there's my plan view there. And I'll take up my extreme generator there, and my center point here. And I'm told that the height of this is going to be 75. So once again, because it's simply inclined, it's going to cut off exactly along that line there. So I connect those together. all I've left from the cone is going to be this section here as a result. So my first point, I can take this line here, it's actually that line there, so that's the extreme generator. I can take that down, giving me that point there, same on the opposite side, extreme generator down there. That gives me 2 points there. Just let that focus. So you can see there I took that line down, and I took that line down there as well. They give me my 2 extreme points. After that, it's just about taking a number of horizontal cuts in between. So the first one I can just take randomly is there. What I do then is, where it hits the extreme generator on the cone, take that down, and I'm going to draw the plan view of that cut there. So it appears as a circle. And where it hits, direct horizontal cut hits the cut there, gives me this point and this point here. And I do the same again, go further down, same idea again, where it hits the extreme generator, take that down and draw the plan view once again. So doing these one at a time, there's no point in taking them all down at once and drawing all your circles, otherwise you become confused with what you're actually drawing. So that's my plan view there, where that cut hits it here and here. And just keep repeating the process. Let's go down to this one, and this time what I'll do is I'll use colour to show it. So that blue is there, that's a horizontal cut, and that's going to appear as a circle in plan. So I take the extreme point out, draw my circle there, and then just use my blue just to go around it to show that that horizontal cut that's blue appears as a circle in plan, and the exact point where that circle cuts is there. Take that down to hit my blue circle below at those 2 points, and then I can take maybe 1 or 2 more cuts then. Maybe just one there, take down the extreme edge once again, draw my circle in plan, and take the exact point where the cut hits. That gives me this point here and this point here, and then I'll just take one more in between then, just this point here. Once again take that down, and this should give me enough points to go by for my question. And that cut occurs there and there, and what I then get is I'm going to get a nice neat freehand curve showing that cut surface then as a result. That's our cut then left behind, and just colour in that surface then. You see it's my orange there, so that's my cut surface there, and that cut occurs between those 2 points. And that's the solution to both of those questions there, so hopefully that video helps.